Assalamu alaikum everyone. My name is Mohammad Asif Khan and I'm a student of Aid University Islamabad. I'm currently studying in 5th semester of Mechatronics Engineering. Today I'm making this video because I've been assigned a task to make a project that is zumo simulation. And I have to basically zumo simulation is a simulation in which we are uh, making a car a simple base to follow a line, simple as that. It is a line following robot. Its command would be executed by interpretation of sensors, and our main task is to interface a SD card with it. Sir initially gave us a simulation, that is which I called before a Zumo simulation. Sir provided us with that simulation. It is already coded and well equipped with the PCB on Proteus. With the simulation on Proteus, and our task was to interface a SD card with Zumo so that the whatever path the robot is going to follow, it would be stored in the SD card. So our main task is that we should interface a SD card with a Zumo simulation in a way that it should record every step of the robot until it stops or reaches its goal. So let's start. For SD card module we need a .mmc file. So let me show you the files. This is the mmc file which I was talking about. You can't view this file. It should be put in the SD card module in the Proteus simulation. This is the path that my robot should follow. From here it will start and it should go whether left from here or straight from here. If it goes left from here, it should make an other left, then maybe right or left, but it could go this way, but it must go this way because our end goal is this X. So I have to program, if by default it went this way, it should come back here and take this path. For example, just I will be remain with this path, that one straight here, then left from here, then right, then left, then straight, then straight, then right. So my robot should follow this path, and SD card should be storing each and every path which the robot is taking. So this was the Rahaber project which Zumo robot should follow. Let's go to the simulation. I've already opened the simulation here. This is my roll number, my name, and what I'm going to do, and this is my semester and degree. First of all, I picked Arduino Uno. You can see from here, that is this. It was already given to us by sir, but I think it is injustice to you guys if I don't describe this to you all. So I'm gonna describe this what it is. If you have already saw my previous videos, you should know that I have mainly used this Arduino 328 because it is an interfacing module. If we want to interface sensors and Arduino and hardware, then we should have data sheet of this Arduino 328 so that the pin configurations could be matched, because in microcontroller systems or any microcontroller device, pin configuration is must. Now let me take you to the further steps. It has a built-in LED which is controlled by this reset button, and here it voltage is coming on this node. It is its reference pin. This AREF, this is reference pin. Now coming to the main thing, which is Zumo. This is the robo. Wait, this part here, which is a red box. This is the Zumo robo, and it has 1, 2, 3, 4, 5, 6 sensors. All sensors are controlled by pins. You can see here Three of them is controlled by analog pins and other three by digital pins, and there here it is common ground. And here it is zumo motor. Zumo have two motors, so positive negative of one motor, positive and negative of other motor. Here you can see the commons of these zumo robo, that is positive for of the battery and negative of the battery. Here this is the buzzer which will let us know how it is going to work or how it is going. Resistor for the overflow, and the button which will complete the circuit, trigger the circuit, and the IO12 and IO3, the pins which will be connected with the Arduino 328P, you can see here. Now second thing, this Zumo Robo, we have to work with this Zumo Robo. This is our input module which will be giving us input, and this is SD card is our output module which will give us the output module. If I press this, SD card will come out, and let me show you. If your SD card is out, simulation won't run. You will see failed, error opening daq.txt. It is not opening file because, wait a minute, SD card is out. The module has nothing inserted in it yet. Let me show you again. If I insert it in, now I run this program, SD card inserted, अब Zumo start होगी, बट Zumo तब तक स्टार्ट नहीं होगी जब तक मैं इसका सर्किट यहाँ से कंप्लीट ना करूँ, शॉर्ट ना करूँ, बटन नहीं दबाऊंगा. मैं जैसे ही बटन दबाऊंगा सिमुलेशन स्टार्ट हो जाएगी. यू कैन सी हियर. And data storing is started. Here you can see each and every path is being stored in this device. Our goal was to make a file which will be storing the SD card values, but I was able to store the value, but I was unable to print that value on a .txt file. So I am storing the values, but I wasn't able to display those values. So here it is the virtual terminal, due to which we could see whether the simulation is being run or not. Let me show you what is the virtual terminal. This one is the virtual terminal which is showing what is happening or what is not. So this was our project. Now let me come on the coding part, on what basis this code is based on. So code is a little bit awkward in the sense that it is already been given to us by sir. So basically I just pick commands of SD card from the IMS project that we were doing last semester, and other commands are from Zumo simulation which were already given to us by sir. So this is Arduino Uno, and starting from the source file. The source file is main file, push button file, and sensors and buzzer motors. Let me just conclude this all in a simple sense. Main file जो आपकी है, it will be concluding of the all main commands which will be calling all functions. Push button is the one which will be initializing the Zumo simulation. It will not run unless I push the button, like I showed you guys previously. QTR sensors.cpp, this is the source file which will be controlling all the 6 sensors. Buzzer one is the source file which is controlling the buzzer sound, that whether simulation started or not, or whether it is completed or not. Motor source file is controlling the initialization and the controlation of the motors. That is, we are using the motors to run the Zumo robot. Then comes the header files. If we started the source file of these respectfully, If we describe these files already, so we need its header file. Push button, QTR sensor, buzzer, motor, exactly those same things again. So SD card file could be opened from this command, my file. Chip select, which I selected 10 IO10. Then we define the threshold of sensors, that is 300. Above line is a helper macro that takes return. One is the sensor is over the line and zero is otherwise. So one means sensor is over the line. That means that sensor is detecting the line. Zero means nothing is here. So one means on, zero means off. So we initialize a function for it. Define above line sensor threshold. Sensor threshold means from ground to the sensor, the distance is 300. And now we will be giving the motor its speed like we do with PWM. We control its speed. हार्डवेयर से स्पीड कंट्रोल नहीं होती, हमेशा कोडिंग से स्पीड कंट्रोल होती है. सो वी डिफाइन टर्न स्पीड. Motor speed when driving straight, speed should always. This speed is for turns when robo will turn, and this is for when it is going straight. Thickness of your line in inches. We describe the thickness of line in inches, that is 0.75. Then comes the inches to units. We convert this inches into unit command, and it is the conversion formula here. Then comes define overshoot line thickness into the unit. Then comes the command where you will be judging the thickness through sensors, and that too in the units, which was already converted from the formula from inches into units. Then comes the zumo buzzer header file and initializing buzzer and reflectiveness sensors here. Reflect sensors mean it will be giving back the values to the command center. And motors को भी initialize करेंगे because they will be running. And button को हमने Arduino की pin 12 के साथ connect कर दिया, from where we will be pushing the button and initializing the whole Zumo robo. Path keeps a log of all the turns made since starting the maze. अब हमने पाथ इसका बनाना है, तो हमने उसके पाथ को एक वैल्यू इनिशलाइज कर दी जिसके तहत वो स्टार्ट करेगा चलना. जब हमने ये एक अरे जब बना ली 100 की, तो उस अरे को हमने 0 से इनिशलाइज करा दिया. अब उसके बाद है सीरियल मॉनिटर का फंक्शन, जो हम वॉइड सेटअप के अंदर बनाएंगे. ये सिंपल कमांड है जो आर्डिनो आईडीई में भी यूज़ होती है. सीरियल बिगिन की सिंपल कमांड आ गई, सीरियल प्रिंट. अब यहाँ पे मैं चेंजेस जो मर्जी चेंजेस कर लूँ वही वहाँ पे चेंजेस होंगे. लेट मी शो हाउ आई कैन टर्न इट. If I write Hasib Zumo here, let's see what happens there. It's taking time. It's compiling. It gave me an error. अब मैं आपको एरर की वजह बताता हूँ. Let's see again. It's working. So I tried to put my function here. Let's try it again. First of all, code should be built. After building the code, then comes the next step. These are the things which should be kept in mind while working. A little error could be done and it will be not working. Let's see what it shows now. It should be showing Hasib Zumo. Here you can see it is showing Hasib Zumo. That's what I was talking about. Let's do it again. This time I gave it an underscore so that it could be shown differently with the space. It can't read space. This is a command of serial print in. That's why the it was printed there. Now come the SD card's chip select. This is the function. If SD card doesn't find the SD card module doesn't find SD card, then it shouldn't be. Then the simulation shouldn't be start. If it else simulation will start if it finds the SD card in it. सो सेंसर 6 है हमारे पास, उसकी अरे बना ली. अब इनको काउंट किया जाएगा हर सेंसर की हर बारी वैल्यू को, और उसके हिसाब से वो फैसला करेगी कि मुझे मुड़ना है या स्ट्रेट जाना है. ये तो वो सारा फंक्शन है जो सर ने ऑलरेडी दिया हुआ था. अब ये माई फाइल sd.open ये वो फाइल है जो हमने यहाँ पे लिखी है. ये वो फाइल है जो क्या कहते हैं असल में काम कर रही है, जो SD कार्ड में वैल्यू स्टोर कराएगी. इनिशियलाइज कर दी फाइल को, फाइल के फॉर्मेट से daq.txt से फाइल ओपन की, उसमें प्रिंट करा लिया zumo स्टार्ट और पाथ ओपन, ये हमने प्रिंट करा लिया उसके अंदर. फाइल क्लोज कर दी यहाँ पर. फिर अब हमने कंट्रोल करा दिया डन, हाँ हमारी फाइल कंप्लीट हो गई. अगर वो नहीं ओपन कर रही तो हम प्रिंट करा देंगे एरर है ओपन करने में, और ये तब होगा जब SD कार्ड वो डिटेक्ट नहीं करेगी. अब बटन की कमांड आ गई, बटन प्रेस होगी तो हमारी सिमुलेशन चलेगी, और बटन का जो कैलिब्रेशन है वो है 0 से 4 तक, और इंक्रीमेंट के साथ इसका लूप चलता रहेगा. अगर उसने पहला डिटेक्ट किया है तो वो काउंटर क्लॉकवाइज मूव कर जाएगा. डायरेक्शन यहाँ पे इसकी हो रही है. अगर वो सेकंड है तो वो दोबारा उसके अंदर चला जाएगा, लूप के अंदर चला जाएगी हमारी कमांड. ये सिलसिला 4 तक चलता रहेगा. उसके बाद बारी आती है वॉइड लूप की. अब इस लूप के अंदर हम अपने लूप फंक्शंस लगाएंगे सारे. ये बजर का फंक्शन है. बजर यानी जब बजेगा तो हमें पता चल जाएगा कि रोबो सिमुलेशन स्टार्ट हो गई है. फिर उसके बाद टर्न के फंक्शन है, कब टर्न लेना है और कब नहीं लेना. अब वॉइड टर्न डायरेक्शन का हमने करेक्टर यहाँ पे बना लिया, और यहाँ आगे इसको अनसाइंड करेक्टर दे के इसको काउंटिंग स्टार्ट कर दी. इसकी काउंट ले लिया, इसका लास्ट स्टेटस इसका चेक कर लिया. फिर सारे सेंसर्स की वैल्यू अरे के अंदर चेक हो जाएगी. अगर वो वहाँ सही होती है तो वो टर्न लेफ़्ट ले लेगा. यहाँ पे अब हम केस बना लेंगे. अगर वो सही होती है तो वो लेफ़्ट ले लेगा, अगर नहीं होती तो वो बताएगा हम बेस पे आ गए हैं. और यही सिलसिला 4 बार चलेगा. और ये सेम फाइल आ गई जो डेटा स्टोर करा रही है. अब मैं यहाँ पे इसकी जगह लिखना चाहता हूँ SD कार्ड वर्किंग. Let's see if it's work or not. First of all, let the code build. Completed successfully, compiled successfully. Now we're gonna run it. Button. Sorry for that. Button is pressed. SD card working. Here you can see SD card is working. Now coming again to the code, this was the code. If the file open okay, then we should write SD card okay. So that means our SD card is opening in the simulation rightfully. If it wasn't opening, then file not opened would have been printed, and it will take a right turn. This same goes for the straight path. First we wrote this code for left, then right, then straight. Then comes the turn selection strategy. What is the strategy for this turn taking machine? So simply, if found left, if it's taking left turn, print L. If it's going straight, print R. If it's going right, print R. So if it's going straight, print S. If it's going to the end, print B. Now path navigation strategy. What part is it is going to take? So this is the zumo simulation part, and I'm not going in its detail because my main task was to work with the SD card interfacing. It's just the elaboration of further zumo simulation, and most of it I have already explained above. So I don't feel I have to explain furthermore. If still you have queries, just let me know in the comment section, and I will make a further video on Zumo simulation. But my main task was to simulate the Zumo simulation with SD card. So I'm just gonna stop here, and coming back to the part where I made changes. I made changes so that you guys know that how to work in the environment at the work time. Let's build again. It will take some time while building the code. Compiled successfully. Now let's run it how it is showing. Hasib Zumo, SD card inserted, Zumo start. Let me push the button for you guys. Start SD card working properly. Whenever the path is completed, it is printing this SD card working properly. So this was our main project. Let it just approach to its endpoint. It will come back. So this was the strategy. I want you guys to know that how this is going to work. This was our SD card module. Let me stop it here. When it reached, it came back. It should have stopped there, but let's see how it's going to do. This is going here, this here, it stopped here. That was our task. This is what I was wanting to told you guys about. This is my complete project. You can see it here. This is, so I will wrap it here. Now I am going to the report section, which is which I have to make still. So it's good bye from my side. Best of luck all of you. We have papers in the coming week. We will meet again. Allah Hafiz.